Assalamualaikum. So this is introduction part of our MEMS capacitive actuator. So our MEMS project has been investigated on radio frequency micro electromechanical system device, that is RF MEMS device. The RF MEMS capacitive shunt switches have been integrated with a CPW line. The ground line of CPW line has been given as S over W over S with values of 70 over 120 over 70. From the structure of the CPW line, it can generate the shunt capacity switch. From the literature, RF MEMS switch that over the higher actuation voltage range can make it difficult to integrate this switch, so that the RF MEMS switch can be designed such it pull in voltage it is IC compatible. VP can be reduced by increasing the actuation area or by reducing the gap or by using low spring constant design. That's all.
In this part, we will discuss about main fabrication simulation. First, we use 7 layout layer for this project, and we also use 6 different types of material such as silicon substrate, silicon dioxide, aurium, chromium, silicon nitride, and polysilicon. MEMS material database include in this main module, and structural mechanic module contain several material commonly used in MEMS application. Each type of the material has its own unique properties such as elastic moduli, Poisson ratio, and density. Next, process definition and 3D model. First layer, substrate wafer. After that, we deposit the silicon dioxide. Next step, we deposit chromium, aurium, and second layer of chromium on top of each other. And in step 6, we start etching the chromium, aurium, and the second layer of chromium. After that, we start deposit silicon nitride, and then we etch it on the next step. For the step 11, we make a sacrificial layer deposition and outer edge sacrificial layer. For the last part, we deposit aurium as the top mask, and lastly we make sacrificial edge to remove the sacrificial layer.
We have 5 different top view design. As can be seen, there are 3 types of diagram, namely geometry in space claim, mesh, and input and boundary condition. Space claim only allows you to move or rotate about one axis at a time. Here are different dimension readings for each design. Next, this is meshing for each design, where it is the process in which the continuous geometry space of an object is broken down into thousand or more of shapes to properly define the physical shapes of the object. The more detailed a mesh is, the more accurate the 3D model will be, allowing for high fidelity simulation. In addition, for each design input and boundary condition, fixed support force or pressure will be applied to it. Fixed supports are used to constrain all degrees of freedom, as you can see in the diagram given.
Okay, this is our group NC's results. For the first graph, when 2000 Pascal pressure is applied to top mask layer, the highest stress is exerted on gold, followed by titanium alloy and aluminium alloy. Next, second graph, we measure pressure versus deformation. When pressure are applied, the highest impact of deformation are on silicon, which is 3.9 meter, followed by titanium alloy and copper, having almost same deformation or approximately 2 meter. This only occur at 3000 Pascal. Next, third graph, when we apply 1500 Newton force, a higher stress is exerted on gold, followed by silicon and chromium. Finally, the last graph, if you apply force between 500 to 2500 Newton to top mask layer, aluminum will have an inclined strain graph, followed by silver and nickel.
Dynamic campuses are now considered small cities due to the large size, population, multiple placement, and various connectivity that take place on the campus, which have serious direct and indirect environmental impact. Environmental pollution and degradation caused by university in form of energy and material consumption as well as residential area could be significantly reduced through an effective selection of organizational and technical measures. Recycled cash, for example, are used to collect recyclable material at universities. UNIMEC and Environment Idaman Sendirian Berhad collect on it. It offers a more systematic and long-term approach to reducing the negative impact of those activities. Next is United Nations Sustainable Development Goal. Waste recycling is an important part of creating a green campus community, as plastic waste has become a major issue both on land and at sea. Green Campus is a community of higher education that promotes energy efficiency and environmental quality by creating a healthier living and learning environment and educating students about sustainability. PET bottles collection system by utilizing a capacitive proximity sensor is proposed. This PET bottle collection system will encourage waste recycling and proper waste disposal and will help the campus become a green campus community.